Okay, so last time I told you that whatever was returned, if it wasn't a zero from a function, it indicative that something went wrong. If the status is not zero, if it's something other than zero, then it's a problem. So it's 5 here. What do you think that means? Well, we didn't call a function. This is just a constant. So if I just type in get last error, the last error will be a 0. So there we go. It's 5 and then it's 0. Now, if you want to know what swshow does, or what does the variable actually represent, I'll give you a hint. It's the W stands for window and S stands for show. And I would advise you to open up a web browser, type in MSDN, and type in SW_show. Now, this is not because I am lazy. I actually want you to go out onto the net and check out MSDN. Because I'm driving traffic to them? Hell no. I just want you to actually know that you have a repository there of knowledge which you can access for free. So just go ahead and have a look at it. There's a very short definition for it. It explains it rather well. And it's, trust me, if you're going to be working with Windows API for making any sort of GUI applications or whatever, you will need to use MSDN as a reference point, because it would be ludicrous to learn all the functions and variables by heart. There are thousands upon thousands of them. Anyway, we're going to go ahead and delete this for now. And we're going to go ahead and jump into the following example, which will demonstrate a simple call of the Windows API function. The program, it will return the time in milliseconds. The computer was running since the last boot up. We will take that time and convert it into hours, minutes, and seconds format. So let's go ahead and see how that is done. Since this is a virtual machine, I'm actually uncertain as to how long it has been running. Okay. And I honestly have no idea what sort of value will I get. So the first thing that we're going to need is the word, something that is very important. The word is a Windows API type, usually is in the format of unsigned int, meaning it's a positive number, positive whole number. So I would definitely advise that you do some additional research on the word, because it is used extensively in the Windows API. And we will go ahead and type in ms, and ms shall be equal. So remember, the word is a type. ms is a variable. So ms is a variable of type the word. I could have written int ms. Except int ms and the word ms are two completely different things, as they are two completely different types. And I will use a function, so get tick count. Get tick count function returns the number of milliseconds since the computer's start. So from the point that I've actually turned it on, it's going to count all the milliseconds and will return them and place them into the ms variable. So std cout, and this will be milliseconds passed after computer started. Okay, ms and std endl. If I just go ahead and save this and run it. Okay, milliseconds passed after the computer started. Okay, this many. I'm not going to bother reading the number, but just go ahead and take a look at it. Now we will take this number and convert it into the format that is more human readable, so to say. So unsigned int hours equals ms divided by 3000. It should be 3000, not 3000, 36, and then 1, 2, 3, 4, 5. This should be right. And then this will convert the milliseconds into hours. So divide by 1000 to get the seconds, and then by 3600 to get the hours. An hour has 3,600 seconds, if you did not know. So unsigned, just a bit of math there, nothing special. Int minutes equals ms divided by 6,000, and then we're gonna get modulus. Not 6,000. Why do I keep on going into 6,000, 60,000? Stuck in thousands today, I'm afraid. Divided by 60. So converting milliseconds into minutes, what do we need to do here? Well, we first need to divide by 1,000 to get the seconds, and then divide by 60 to get the minutes. A minute has 60 seconds, hence we shall divide it by 60. And then we will take the modulus so that it is in range from 0 to 60. So divide by 60 and divide by 1,000. That would be 60,000. And then take the modulus 60 so that we would get a specific range from 0 to 60. Okay. Unsigned int. How a modulus works and why it is used, well, that was explained long ago in the beginning chapters. Seconds equals, and here we shall have ms divided by 1,000. Then again, we shall take modulus, and it shall be 60. Divide by 1,000 to get the seconds, and that's pretty much it. After that, we will simply take the modulus so that it is in 0 to 60 range again. Once again, down below, we will create our printout. Okay. So that is hours, and let's make it a little bit prettier. Minutes and okay, seconds. I could leave it in one line, but I'm not. I'll just do it like this. S and it should be std and L. Okay, so this is just me formatting the output, nothing else really. So let's just go ahead and build and run. So milliseconds passed after computer started, it's this many. And then down below, we have a conversion to a human readable format. It's 7 hours, 20 minutes, and 31 seconds. A fairly precise measurement. If there was a remainder of milliseconds, I guess we could actually place that here as well, but that's not the format that we were aiming for. Simple as that. We see that we can get some useful information from the Windows API. Also, we have learned the D-word type, which is right here. I would suggest that you read up on it further on MSDN. And Windows API contains a large number of these types, which are synchronous for some C, C++ types as well. The word stands, the shortcut basically stands for double word and word. So double word and word, is basically int. Double word is double int, and that is actually an unsigned int pretty much. Simple as that. As I said, I might have given you a bit of a messy explanation of what the word is, but I would strongly advise you to go out onto the net and just go into the MSDN, dig in it. It's really well written out. There are no difficulties for you to actually go through it. By the way, the keylogger that I've written in the keylogger course was actually written through the usage of the functions from the Windows API. Why? Well, why would you write custom functions for the keylogger, custom headers, libraries? That would create additional dependencies. You would have to have those libraries, and that could be problematic. why not use the existing libraries in Windows and have them work for you in a way you want them to work? Aside from simplifying the project and making it a lot easier, it has a double effect, so to say. The keylogger has a greater level of stealth, so to say, because it is not using anything else. It's not using anything out of the ordinary. It's using pretty much the same things that most of the other applications on the system are using as well, and in pretty much the same way as well. That's why it's so difficult to detect it. Anyway, gonna bid you farewell here, and hopefully we shall see each other in the follow-up tutorial.